All right, guys, back at the drawing board, and we're working out a problem. It's a little bit longer. I just want you to understand that you still use the same concept. You would follow the same rules. And of course here, because this is in parentheses, we would send in the distributive property multiplying this by the number 5. However, let's look at the sign in front of the number 5. It's negative. So I'm just going to make sure you understand that you're multiplying everything inside the parentheses by a negative 5, okay? So I'm just going to go ahead and multiply. Negative 5 times 3 is a negative 15x. And a negative 5 times a negative 6, which 2 negatives would make a positive, what? It'll be a positive 30. And I'm going to rewrite the rest of this problem. That means I'm going to bring down every number that we didn't touch, okay? So here we didn't touch 2x, equal sign, negative 7, and 9x. And so if you look at my problem, I have 9x minus 7 equals 2x minus 15x plus 30. Well, one thing I noticed on this side is we have two like terms. I want to clean that up a little bit. Don't want to leave it like that. I want to clean it up so that I won't have to take it. And because I'm not taking it to either side, I'm just cleaning it up because I have two like terms. I'm going to rewrite this. A positive 2x minus 15x is now a negative 13x. Okay? And now I'm going to rewrite my problem. And these are the numbers that I didn't touch. So, negative 13x plus 30. And I use my 2x there in that one. So I'll just put the equal sign. And then 7 minus 9. That's not a cute 9. 9x. Okay. So now my problem is 9x minus 7 equals negative 13x plus 30. Well, I want to remove my x and put it over there with my 9x. So don't want to use purple this time. Let's use red, but since we use purple for the 13, okay? Okay, so since this is a negative 13x, I definitely want to use the opposite sign and the same number so that that number can go to 0. And I'm going to do the same thing here. This is a positive 13x. And I'm going to draw my line so I can carry out the either subtraction or addition. 13 plus 9 is definitely 22, and it's positive, so 22x. And I'm just going to bring down my negative 7 equals, and that's 0 now, of course, 30. Okay. Now, what do you notice? First of all, that I can use purple. That's one thing. However, I see that I can move my 7 over to this side so that can actually isolate my x. So in order to do that, since I have a negative 7, I would add a positive 7 here and also a positive 7 there. Draw my line. Rewrite my problem. 30 plus 7 is 37 equals, and of course that cancels out, 22x. All right. So as before, as stated, since this problem here, this variable, this number is actually held by a multiplication here, I'm going to use the opposite and divide it by 22 to cancel out. Okay, if I did it to this side, I also need to carry out the same function over here, which would be 37 over 22. Now, let's rewrite this problem to see what I have left and to see if it can be reduced. X equals 37 over 22 is my answer because it can't be reduced. It could be changed into improper fraction if it asks you to move that far, simply because the numerator is greater than the denominator. So you just do that by dividing 22 into 37 to get that final answer. But here's a final snapshot of the steps. And as you can see, the functions carry out the same way every time in algebraic expressions. Honestly, you would use work whatever is in the parentheses first. If that's not the case, you would look what's on the outside and multiply it on the inside and carry out the functions till you isolate one side where you're solving for x, okay? It would carry out the same way as the first problem, the second one, and I'm going to work one additional problem before uploading an assignment for you guys. Thank you.